Hi friends, let's look at today's daily challenge problem. Find unique binary strings. So here we are going to solve this problem by diagonal principle, so which is actually very easy to digest. So later we are going to give you a walkthrough. So here we are given an array of strings called nums containing n unique binary strings, each of length n, right? So we want to return a binary string of the same length that does not appear in nums. And if there are multiple answers, so we may return any of them. So this problem actually is very easy in the sense that the requirement for the return. So we just need to find one that are different from the n in the given list of strings. So here, let me explain how I do this. I'm going to use example 3. So it's the so-called diagonal principle. So let me copy this here. So the procedure is that we look at each of those. So this is at index 0, this is at index 1, this is at index 2. So for at index 0, so we want to, our goal is to construct a result string. So let me first use some list to represent that of length 3. I want to go to make that the result list at index I will be different than nums I at index I. So this way, at each position, we are going to different from one of those. And overall, the result, if you do the return, I'm going to do a join, right? Array afterwards. So this will be different. So let's use this one. So at index 0, so the first string has at index 0 has 1. So I'm going to have a result that is 0. And then this is at index 0. We got this. We can use append operation actually. So at index 1, so we look at this second one. So it's a 1. Now I'm going to append a 0 again. Right. So at index 2, so this is 1. I'm going to append 0 again. 0, 0, and 0. Then the result string, this is the list you are going to join it, will be consider every string in the nums. There at least one position is different from the result string. So the result will be different from all of the strings in the nums. So that's the diagonal principle. Diagonal means here Ri, right? Let me first write the code, and then we can also analyze, say, example 1 or 2, say in the same fashion. So what we want to do is we have a result variable, and then we are going to iterate for I and say array in not array, string in enumerate nums. Then what we want to do, we want to have a candidate, right? Candidate. So maybe I can write like this. The character or the digit is s at I, right? So our candidate, so it's actually not necessary to introduce those variables, but in order to make it more clear, so I introduce this one. So candidate will be 1 if a character equals 0. Otherwise, it will be 0, right? Then I'm going to append this candidate. And then what I'm going to do, I'm going to return John this result. So now we can, check this, right? You get 0, 0. Of course, it's different from this one because this is not unique. And then let's look at the generic case. Yeah, it passes very fast. So if you have still cannot digest that, so you can look at the example 2, for example. So the first one is 0, 0, right? At index I equals 0. So then what I'm going to do is to have a result equals this 1. And then at index 1, you have 0, 1. So now I'm going to, because this position is 1, I'm going to append a 0. In other words, return 1, 0 based on our solution. So this solution actually very fast, right? You just need to linear scan this nums. So this is the one way. So here, let me end this video by a extension question. So maybe it's a good practice, right? So given this n is not very large, right? So can you generate all the binary strings of length n, right? Then you can return it as a set, right? You have a set of length n binary strings. Then you can minus the set of nums. So, right. So this way you get you can return any element, any atom in the difference set. So the exercise will be this: can you generate all the binary strings of length n? So with that said, I guess that's it for the current video. Thank you for watching.